classroom wanting to teach you why it is that chemistry matters in biology. And what we're going to do today is I'm going to focus on one small aspect of chemistry and hopefully help you understand how to read the periodic table. And in biology, what we are really focused on is the number of electrons in an atom and how many electrons are located on the outermost energy shell. Okay, well, I'd like to begin our tour through the periodic table by looking at the simplest element. We're going to look at hydrogen. And the first thing I'm going to do is I want to help you understand what you see when you look at a periodic cell. And then I want to eliminate the information that you really don't need to know anything about for biology. When you look at a periodic cell like this, we have a symbol. Here, the atomic symbol for hydrogen is the capital letter H. We have the atomic mass. And this is the mass of an element in AMU's, atomic mass units. And it is equal to the number of protons plus the number of neutrons. But we don't care about this in biology. So really, we can ignore the atomic mass in this class. And then we have the atomic number. The atomic number is a really important part of the periodic table when it comes to biology because it explains how certain types of elements will bond or combine together. And we'll learn about how those elements bond later this week. But really, right now, what I want to focus on is what the atomic number means and how we can use it to understand the number of electrons in an atom. Okay, so we don't care about the atomic mass, so I'm just going to eliminate it. If you take AP Chemistry, then great, you can do whatever you want with the atomic mass, but for our purposes, we're just going to ignore that. And what we're going to do is we're going to focus on the atomic number, and if you're hydrogen, your atomic number is 1. Atomic number is equal to the number of protons. So based on this, we can say that the atomic number in hydrogen, 1, means that hydrogen has 1 proton. So what? Who cares? Well, it actually turns out that that 1 proton really means something. It really matters. It turns out that a proton is a positively charged particle. Therefore, we can say that hydrogen has 1 plus charge. But it turns out that every single element in its native state is neutral. So if hydrogen's atomic number is 1, which means that there is 1 proton, and protons equal a positive charge, so hydrogen has 1 positive charge, but atoms are neutral, I've left you with a paradox, and that is, how are we going to make this atom neutral if hydrogen has 1 plus charge? Well, it turns out that the atomic number not only tells us the number of protons, it also tells us the number of electrons. So, because hydrogen has an atomic number of 1, it has 1 proton and it has 1 electron. So what we want to focus on now is where can we find the protons and electrons on an atom. And that's what I'm going to do next, is we're going to look at an atomic diagram. I'm going to show you where the protons are and then I'm going to show you where the electrons go. Okay, so we've now found that the atomic number of hydrogen is 1, which means that there's 1 proton, which also means there's 1 electron. And if I were to pull out a simple Bohr model of the atom, what you can see here is the red dot in the middle, which represents the core of the atom. This is the mass of the atom, and this is where you can find the protons. Well, we need to balance that out, and the balance is the electrons, and the electrons appear on this atom, but what they're doing is they are spinning around the core. They're traveling at the speed of light, zooming around in what we call an orbital or a shell. And so here is our 1 electron on the outer shell surrounding the atomic core. When we look at this atomic structure, we always look at how many protons are in the core and how many electrons are spinning surrounding that core. And you need to remember that they don't move in a simple orbital like this. They move in spherical space. They're essentially around the core. And you'll notice that the very first question it asks is, what is the number of electrons in the atom? And so what we're going to do is we're going to look at our atomic number. Remember that the atomic number, which tells us the number of protons, is equal to the number of electrons. And therefore we can easily say, hey, there is 1 electron in this atom. The next question asks us, how many electrons are there in the first energy shell? And so if we look back at our Bohr model, and again, that is the same picture that you can see. So if you look here for the hydrogen, it's essentially what I have up here for you. And you can see that there is 1 electron in the second shell. Number of electrons in the third shell? Well, or rather, the number of electrons in the second shell is 0. The number of electrons in the third shell is 0. And then the last question asks us, how many covalent bonds can this atom make? At the hydrogen atom, it turns out that this shell can hold a maximum of 2 electrons. So what that means is that there is a vacancy here on the first shell, and that vacancy tells us, hey, hydrogen can make 1 bond because it's looking for 1 electron. That's the key. We want to find out how many electrons are needed to fill the shell. And the first shell surrounding the nucleus holds a maximum of 2 electrons. Therefore, there is 1 vacancy here, and hydrogen can make 1 chemical bond for its 1 vacancy. Here, notice lithium has an atomic number of 3 and an atomic mass of 7. We don't care about the atomic mass in biology. All we care about is the atomic number. If lithium has an atomic number of 3, how many protons does it have? Okay, hopefully you thought of the answer and you came up with the number 3. That's correct. Lithium has 3 protons. How many electrons does lithium have? Well, you are all geniuses, so I'm sure you remember that the number of protons always equals the number of electrons. So if lithium has 3 protons, clearly it has 3 electrons. So to summarize, okay, well, our next task is to place the electrons around the nucleus of lithium. Remember, there are 3 protons in the nucleus of lithium, and now we want to place the electrons on the energy shells that surround the lithium nucleus. So when we look at this, you've got to think to yourself, all right, how many electrons fit on the first energy shell? And remember, we said on this key information, the first energy shell can hold a maximum of 2 electrons. Our lithium atom, I can grab an electron, I'm going to place 2 electrons on the inner shell, and those 2 electrons are moving, they're moving at the speed of light, and if this electron moves here, then this one's going to move here, and if this one moves here, then this one's going to move here, and they're in constant motion. But remember, lithium has a total of 3 electrons, and we've got to place that 3rd electron somewhere. Try to squeeze the 3rd electron here. The negative charges, they repel each other. Negative charges don't want to be together, so the end result is that lithium electron, boop, gets pushed to an outer shell. So now this electron is moving around at the speed of light on this outer energy shell, while these 2 electrons are pushing each other along on an inner energy shell. So now we can place the 3 electrons, 2 on the first shell, 1 on the outer shell. Our next task is to complete the table for lithium. So if I were to do that, I could put the atomic symbol here, lithium, number of electrons, 3. Number of electrons in the first energy level, well, that holds a maximum of 2, and it's now full. How many electrons are on the next energy level? 1. Is there a 3rd energy shell? No, because lithium only has 3 electrons, and so we can place a 0 here. So we want to now figure out how many chemical bonds lithium can make. And the answer to that really depends on the number of electrons that that 2nd energy shell holds. And in reality, lithium forms something called ionic bonds, but if it were to form bonds like hydrogen, we could look at that 2nd energy shell and say, all right, how many electrons are needed to fill it? And it turns out that while the first energy shell holds a maximum of 2 electrons, the 2nd energy shell holds a maximum of 8. So now we want to figure out, all right, how many vacancies are there on that 2nd energy shell? Well, 2 electrons on the first shell, max of 8 on the 2nd shell, and we have 1 there. So if we have 1 electron on this 2nd energy shell, how many electrons do we need to add to get to 8? And the answer? Turns out that there are 7 vacancies, and therefore we can make a total of 7 bonds. Okay, with 1 electron on the outermost shell and 7 vacancies there, we can say that lithium could make a maximum of 7 covalent bonds. This, like I said before, will never happen. Instead, lithium will give up that electron and become ionic. But just for the purposes of this assignment, what we could do is in this slot here, we can say that there are 7 possible covalent bonds.